Hi friends, welcome to Eltechpedia. Today we will see about the voltage regulation, determination of voltage regulation of the alternator by using Ampere Turns Method or MMF method. In this method, the effect of winding impedance and armature reaction are equivalent to Ampere turn. Hence, it is called as Ampere Turns Method, that is MMF method. RA is usually very small and XL is also small. For low voltage on short circuit, impedance drop can be neglected because of RA and XL is very small on a low voltage. This method gives the result is less than the actual result, so it is referred as optimistic method. In synchronous method is called as pessimistic method because the measured value is always higher than the actual value due to the consideration of saturation. But the MMF is the optimistic method. EMF method is the pessimistic method, MMF method is optimistic method because of the measured value is always less than the actual value. Then the percentage regulation, we know about the formula. Percentage regulation is equal to E0 minus V divided by V into 100. This method utilizes the OC and SC data and converts the EMF method, in the sense that the armature leakage reactance is treated as additional armature reaction. So same data of the OC and SC test of EMF method is utilized to draw the characteristics of MMF method, and then it will be used to find out the voltage regulation for corresponding field current. Then we will see about the one problem. Here mention the open and short circuit test readings for a 3-phase star connected 1000 kVA 2000 volt 50 Hz synchronous generator, or the field current is 10, 20, 25, 30, 40, 50, and OC voltage and SC currents are listed here. The armature effective resistance is 0.2 ohm for phase. Draw the characteristics curves and estimate the full load percentage regulation at 0.8 power factor lagging and a 0.8 power factor leading. So first we have one graph for IF versus VOC, IF versus ISC. So first draw the characteristics. Before that, here they gave the value of OC terminal voltage is considered as line voltages. So we will find out the phase voltages. Here the 3-phase star connected alternator. So 3-phase star connected. So star connected means V phase is equal to VL by root 3. So the given values of the VOCs are divided by root 3. So 800 divided by root 3, 1500 divided by root 3, 1760 by root 3, 2000 by root 3, 2350 by root 3, 600 by root 3. It will give them phase values are 462, 866, 1016, 1155, 1357, 1502. The full load phase voltage is equal to, that is the rated voltage of the alternator is 2000 volt, 1000 kVA, 2000 volt. So here mean that 2000 divided by root 3, because there also gave the value of line. So we know the value for phase. So 2000 divided by root 3 will be produces 1155 volt. Then full load current, we know the formula for I is equal to kVA divided by root 3 into V. So kVA value 1000, so 1000 into 10 to the power of 3 divided by root 3 into 2000. So IL value is 288.7 amps. The voltage for phase at full load power factor, that is E is equal to V plus IRA cos pi. We know the value of I and we know the value of V. So V equal to 1155. I is equal to 288.7. So here mentioned E naught is equal to 1155 plus 288.7 into RA value 0.2, cos pi value is 0.8. Finally, we get the value is 1200. Before that, we will draw the graph for IF versus VOC, IF versus ISC. So the VOC values are 462, 866, 1016. Here calculate the value for VL by root 3. So first we draw the graph here. So here consider the graph, the x-axis as IF, x-axis as IF and y-axis as y1 as VOC. Here mention and draw the plot for VOC and ISC. So the OCC characteristics is drawn between IF versus VOC. So mention the field current. Here the field current values are given. So this is the field current values 10, 20, 25, 30, 40, 50. The corresponding VOC values are 462, 866. So draw these characteristics, and also ISC characteristics. 20 has 200 amps, 25 has 250 amps, 30 amps having 300 amps. So draw the VOC ISC characteristics. Mention, mark the points and draw the characteristics. The OCC characteristics as the freehand sketch, but in SC characteristics as straight scaling as draw. So first mark the points and draw the freehand, but in SCC marked with using the scale. So then we will find the value of E naught. Here find the value of E naught is equal to 1200, and also current IL is equal to 288.7. So mark these 2 points in a graph. So in a graph 1200 here, the y-axis 1200 here it will be hit to OCC curve. Then we will calculate the value of IF value. It is 22 amps. In a IF, the 1200 will be hit to VOC curve. It has 32 amps. Then we will find 288.7. It will be hit to ISCC current. So ISCC characteristic, this have the value of 29 amps. First we find the value of E naught corresponding IF, then ISC corresponding IF. So 1200 will be hit to in a OCC characteristic. We find the value of IF, that is IF1 is the 32. Then we will find the ISC load current. IL is equal to 288.7. It will be hit the SCC current. We have the value of 29 amps. Okay. Then we will find the cases. Here we mention the two types of cases. Case 1, power factor 0.8 lagging, then power factor 0.8 leading. The IF value will be finded for power factor 8 lagging. It has the formula square root of IF1 the whole square plus IF2 square plus 2IF1 IF2 cos 90 minus pi. For lagging, cos 90 minus pi. IF1 already I told here, the VOC will be hit the OC curve, then we will get the 32 amps, and ISC hit the in SC curve, we have the value of 29 amps. IF1 IF2. So consider here. Then phi value, we know the power factor cos pi is equal to 0.8. So power factor is equal to 36.86. So here substitute the all values, IF1 IF2 cos pi value. So IF1 is the 32 and IF2 is 29 square into cos 90 minus 36.86. So finally we get the value of 54.6 amps. Then we will find the corresponding E phase value for 54.5, that is 55. we will dotted here marked in a OCC curve. So the 55 will be hit in a OCC. We will find the E0 value as 1,555. The E0 value as 1,555. So it will be marked as 1,555. Then calculate the regulation. E0 minus V divided by V. V is the constant. 1155 for this sum. So 1,555 minus 1155 divided by 1155 into 100. So the percentage regulation is 34.6 percentage. For second case, 0.8 leading IF is equal to same IF1, IF2, 32, 29. But here cos 90 plus pi. For leading cos 90 plus 5, for lagging cos 90 minus pi. So substitute all values, we get the value of IF is equal to 27.4, that is 25, that is 28, nearer to 28. So here marked 27.4 and hit to OCC. Where we need the value of voltage, we will directly hit to the OCC. Once you know the current, we will calculate the current means you will go to hit and find out the SEC curve. Okay, where the OCC, that is where the voltage or induced EMF will be determined, there the field current will be hit to the OCC curve and find out the voltage value. So 27.4 will be hit to the OCC curve. We find out the induced voltage E0 is equal to 1080. Then we will find the regulation. E0 is 1080 volt, percentage regulation is 1080 minus 1155 divided by 1155 into 100. The percentage regulation is minus 6.4 percentage. This is the types of MMF method problem. If you like this video, like and share to your friends and comment this video. Thank you friends. Thank you.